Oh, Aniq. Hi, and assalamualaikum everyone. Ladies and gentlemen, today we will present our fighter. Okay, here we go. First, in the left corner, we have Aniq. Second, in the right corner is Aqmar.
Step up, bring it. Yes, sir. Somebody gon' get their ass kicked. Somebody gon'
And the last one in the mid is Aidiel. Oh, I forget to say my name. My name is Raja, your referee on today. Next, let's presentation begin.
Definition of vector. A vector is an object that has both a magnitude and a direction. Geometrically, we can picture a vector as a directed line segment, whose length is the magnitude of the vector and with an arrow indicating the direction. The direction of vector is from its tail to its head. Next, we have vector example. So, vector example, we have displacement, velocity, acceleration, force, and momentum.
In real life application of vector, OA plus AB same OB same 2B, AB same 1.5C, OB same 3B plus 1.5C.
Definition of vector inline survey. Inline surveying vector can be used to create a map. This map is called vector map, and another type of map is called raster map. Vector data format consists of point, line, or polygon. At its simple level, vector data comprises of the individual points stored as coordinate pair that indicate a physical location in the world. For example, a city may be represented by a point, a road may be represented by a collection of lines, and a state may be represented as a polygon. Raster data is any pixelated or gridded data where each pixel is associated with a specific geographical location. The value of a pixel can be continuous, example elevation, or categorical, example land use. If this sounds familiar, it is because this data structure is very common. It's how we represent any digital image. Image real world, image vector, and image raster.
Now watch this video of this guy that is known as Dave from the YouTube channel Professor Dave Explain.
Say you are in a boat traveling across a river, and the boat typically moves at 4 meters per second in still water. But the current is pushing you downstream at a rate of 1 meter per second. What is the speed and direction of the boat? To answer this and almost any other problem we study in physics, it is best to draw a diagram first. Here's a top-down view of the river and the boat. Let's draw a vector that is horizontal with a magnitude of 4. We then need another vector to represent the current. That will point straight down and have a magnitude of 1. To find out the speed and direction of the boat, we have to add these vectors together. In order to do this, we can move the vector that represents the current over here, so that we are adding head to tail, and then find the resultant vector. Or we could have left it where it was, made a rectangle using the two vectors, and then just drawn the diagonal. Either way, this vector sum will have a magnitude of √17. To find the angle from the horizontal, we can use any trig function we like. Say we use tangent. Tangent theta will be opposite over adjacent, or 1/4. Taking the inverse tangent, theta must be 14 degrees. So the boat is moving at a speed of √17 meters per second in the direction of 14 degrees off the horizontal. It may seem abstract right now, but we will be using this sort of approach in order to understand motion in almost any situation you can imagine, because it's just about using vectors to represent the forces acting on any object.
In conclusion, vector can be seen used in military, sport, science, physics, astronomy, game design, traveling, geography, and etc. Vector can help us represent three-dimensional space using vector. We do 3D geometry completely using the properties of vectors. Any problem in science which has to deal with the direction component has to be done with the help of vectors. Surveyors use vector to create vector type map that is consists of line and dot. Surveyors also use vector to find the shortest path between the two locations.
Astaghfirullahaladzim. Pardon me. Okay, we just arrived in the end of the slide. Thank you for everyone for your wait with the lesson and your pay attention to our slide. And goodbye.